Hello everybody, this is Shahaf. I'm here today with a special guest. Now, as we've recently announced, we've launched the COTI Ecosystem Growth Fund, a fund that is dedicated to funding development, research, partnerships, and other initiatives that grow the COTI ecosystem while upgrading to a privacy-centric Layer 2 on Ethereum. The first funding has now been allocated to Sodal, a leading player in MPC, to accelerate privacy enhancement in COTI V2. Now, today, I have Dr. Avishay Yanai with me. He's one of the founders of Sodal and its CEO, and we'll discuss what Sodal contributes to the COTI V2 ecosystem with their breakthrough technology around Garbled Circuit research. So without further ado, I'd like to introduce my guest here, Dr. Avishay Yanai. Avishay, the COTI community already knows me. They heard too much about me as it is. They would like to know you. So if you can tell me about yourself, your experience, and what brought you to cryptography and Garbled Circuits.
So first, thank you for having me today. I'm in the cryptography space for about 10 years now. And I started my journey as a master and PhD student in the field of cryptography. I've been working on a lot of problems related to privacy, anonymity, blockchains, with the privilege to work with top minds in this field of cryptography and distributed systems, like Yehuda Lindell, Benny Pincus, and Itai Brown, and more others from all around the world. And I've also been working as a researcher in a VMware research group, working on the same set of problems, solving a lot of problems and improving efficiency of them. And recently, me and Meital Levy have founded Sodal, which brings to life all the academic improvements into life and production.
Okay, so both of you guys are PhDs in cryptography, right? And algorithms. And you've done extensive research around Garbled Circuits, right? Which brought you to the funding of Sodal. So what can you tell me about Sodal?
So the main goal of Sodal is to be an enabler for processes for individuals and organizations that could not be conducted otherwise without privacy. So right now there is a lot of data belongs to individuals and organizations, and because they are concerned about their privacy, they could not or are not willing to share it with anyone else, and therefore they could not gain insights about it and cannot do some research or gain some scientific results about that. And with a proper privacy infrastructure, we can enable those organizations and individuals to gain all the useful part of their data without compromising on the privacy side.
So you did mention privacy, and so why did you choose to focus on privacy? Is it because of all the new use cases that can come alive with privacy? And with that, why do you feel that privacy is so important?
So I think about it on the other way around. I think that the real question should be why one would give up its privacy. And I think privacy should be given as default and not as a special care. And this is also reflected by the fact that privacy is one of the human rights, basic human rights stated by the United Nations. And I think about privacy always. When I'm doing some actions, it can be actions like in real world, like going to the supermarket and deciding whether I want the receipt to be physical or digital, and whether it is on like the digital world on computer and everything. So most of the people do care about their privacy. Some of them just say it's I should not afraid of like
I have nothing to hide.
I have nothing to hide. And actually, when you ask them to give you your their phone and show all the messages to everyone in the audience, they tell you no.
Yeah.
So they have something to hide. They just don't know it.
Yeah, but they know they know they do, and I have to agree. And we were discussing this earlier, that the way the internet has evolved from the protocols not allowing any form of encryption to how encryption came about in the internet, and the SSL moment of the internet. So we both strongly feel that blockchains will have their SSL moments in the coming years, where public ledgers will not allow free access to sensitive information, because until this happens, we are limiting all use cases around us. Okay, great. Let's move on to the next question. So one of the concerns that people had when we were talking about COTI V2 was, but wait, exchanges delist some privacy tokens, and privacy is illegal, and all of that, which obviously is a misunderstanding of what anonymity is, or mixers are, to what confidential transactions are and privacy really is. But can you kind of like elaborate more about this, about what is a confidential transactions, and what's the difference between that and anonymity?
Yes, so obviously the terms confidentiality and anonymity and privacy, these terms are a little bit interchangeable in the literature. So each book or paper may define them differently. But in my view, I think about anonymity as the possibility for someone to take an action, but without being identified. So everyone can see what has been done, but not who have done it. And so this is about, I call it the metadata. So the metadata is hidden. Here the metadata is the identity of the person who did that action. While confidentiality means that there is an action that have been done by someone. We know who is this, but we don't know exactly what was the action. And this kind of privacy, I call it data privacy, not the metadata. If you consider both metadata and data privacy, then you get like a full, the widest range of privacy. And the current concern in the market about mixers and anonymity is that we don't know, we cannot trace money laundering, and we cannot trace terror organizations that uses blockchains for bad actions. So we decided, although it is possible technologically to hide the metadata, the guys who did the action, we decided at first focus only on the data and not on the metadata, which I believe will be perceived better in the market and will not raise the same concerns.
Yeah. So in fact, like, we have regulations and rules against money laundering, obviously, and hiding who's behind a financial process. Hence, we call it know your client, right? But we also have rules for privacy, to maintaining privacy and sensitive data like GDPR, etc. And this is the main difference, and this is our core focus when building the network. So let's get to the juice of things and talk about Garbled Circuits, which when I told one of my friends we're going to do something around Garbled Circuits, he said, "Oh yeah, I love all their songs. I love the band." So I guess most folks don't know Garbled Circuits, even though I know Vitalik Buterin talked about this and a few others recently. But can you explain in layman terms what are Garbled Circuits and Garbled protocols?
Yeah, so first, a lot of people hear about the terms MPC. It's more common in the market because
multi-party computing.
Multi-party computation, because it is mainly used to represent a specific type of function, which is a collaborative signature. This is the main use case of this term right now.
And we see this where in like companies like Fireblocks, right?
Yes.
And maybe wallets like Zengo and others,
exactly.
Safe.
Yeah, the main use case is for wallets who want to allow many people to collaborate on the same signature on one transaction.
So like hold pieces of the secret of the key.
Yes.
And collaborate together to kind of like solve something or open something. Yes. So this is MPC.
It's like if you want to like physically sign on a paper, then if we have 10 signers, then each signer just write a little bit of the signature.
Yes.
So this is the analogy in the physical world. But actually secure or multi-party computation in general is not related to this specific use case of signature. It is actually much wider. It means that this set of 10 people can do any operation together on any secret. So they have pieces of secrets, and then they want to do some operations about those secrets without combining them. So each one has only a piece of the secret, but they can still do operations on the combined secrets without combining them.
Okay, what do you mean by operations? Like what sort of operations can they do?
So theoretically, any operation can be done. So, but we, like in computer science, we talk about computational models, and we break the functions into kind of representations. So we represent functions by, for example, a set of additions and multiplication operations in some of the computational models. In others, in the logic computational model, we break the function into AND gates, logical gates, and XOR logical gates, and OR, and so on. There are many other computational models in the literature, but these two, for example, are called arithmetic and Boolean computational models, and they are the most popular in the field of cryptography, both in multi-party computation and in zero knowledge. And this is the same computational models that we are working on with Garbled Circuits. So Garbled Circuits is a type of multi-party computation. It's a tool to implement multi-party computation, where actually we put the function that we want to compute inside the black box. Nobody can see what's inside the black box, but we can turn on a button that initiates that computation of the function. So everything that happens in the black box, which are the intermediate values that the function obtains, they are all remains sealed, and nobody can see that. And usually only the output of the function is getting out of that black box. But also that can be
encrypted.
Also that can be encrypted if you want to keep doing some operations later on that output. So yes, so Garbled Circuit is that implementation of the black box, is a mathematical implementation of that black box that allows us to do that.
So the idea is that from the outside, nobody sees the function, what it computes, just the output.
Yes, and even the output can be sealed as well. It depends on whether we want to allow it or not.
Okay, but like, what are the advantages of Garbled Circuits in the context of blockchain?
First, Garbled Circuit was the first implementation or first tool used to implement that black box or that multi-party computation protocol that was proposed ever. It was proposed by Andrew Yao at 1982. And since then, it was proven secure formally, and a lot of research have been done about it, including my own research. And part of garbled circuits, there were other tools that were invented in order to solve that multi-party computation problem or functionality. For example, there are MPC protocols that are based on the secret sharing approach. There are other protocols based on the fully homomorphic approach called FHE. And the advantage of garbled circuit is that it doesn't matter. Basically, this is its premise is that it doesn't matter what is the complexity of the function that we want to compute. The amount of back and forth between the parties is going to be constant. And this constant is quite low. So we know for sure that whatever computation we'll need to do will only be needed to talk only, for example, 3 or 4 times, and that's it.
So you're talking about gobbling circuits having a major advantage in terms of latency, of low latency, right?
Yes.
And communication speed. Okay, but let's kind of like focus that and kind of compare gobbling circuits and what we're doing here to systems that people might know, right? So let's start with something that I guess everybody knows, zero knowledge, right? Zero knowledge proofs. So let's begin by saying that there are ZK rollups where zero knowledge is used for scalability, not for privacy. And we're not talking about this because it's irrelevant to privacy. When we're talking about zero knowledge in terms of privacy, can you kind of like compare a few parameters between gobbling circuits and zero knowledge? Let's start maybe with scalability, which we've discussed.
There are several metrics that are relevant if you are speaking in the blockchain space. Then one of them is interoperability. The other is privacy, and maybe another one is efficiency. Now, if you compare, in general, multi-party computation solutions versus zero knowledge, then those MPC solutions, they have the interoperability feature, whereas ZK doesn't. So ZK enables one to prove something about its own data when the person knows everything about the data.
Yeah.
It can prove something about it, or it can prove that some statement about the data is correct. But if someone wants to prove something about the combination of its own data and the data of someone else, then this is no longer possible with zero knowledge. And this actually can be solved with protocols in the MPC domain.
Sure. So when we're talking about zero knowledge in terms of privacy, so obviously the most well-known use case probably is identity, right? I can prove that I'm, say, over 18 or from the US because I have this data, but it remains there in decentralized identity. Whether if you'd wanted, for instance, to build a DEX or voting system or stuff like that that requires privacy and interoperability between a few folks, then you couldn't do that with zero knowledge. So the big problem here is the sort of apps that you can build with zero knowledge.
Yes.
Now, in terms of computation speed, zero knowledge versus gobbling circuits?
Yeah, so zero knowledge has, on its own, it's a research field on its own, and it has a lot of possible implementations. Some of them are fast, and some of them are not. And also, those that are fast, it's not always fast. It depends on who runs it. So, for example, solutions that needed to be run by a rollup they can afford a very, very expensive computer, whereas users, if they want to prove something, they cannot afford that. They need to run they need to compute their proof on their low power device, and this is very challenging. So we are witnessing such limitation for zero knowledge proof solutions, where users who have some older phones, it takes a large amount of seconds to compute a proof, which makes the user experience
bad.
very, very bad.
Yeah.
In the field of MPC, there are also a range of solutions. Some of them have the same limitations. So as I mentioned before, fully homomorphic encryption, it is quite difficult to do the computation. Whereas other solutions like those based on the secret sharing and garbled circuit, in those solutions, it is usually easy to do that computation. So even a low power device can perform that.
Gotcha. So gobbling circuits can run on any device. Some MPCs can run on any device. Zero knowledge, probably not, and FHE cannot run on any device. With that in mind, in terms of speed, my understanding is that FHE is quite slow and expensive today at 2024. Maybe with some futuristic hardware, it will be faster. And gobbling circuits, just in terms of latency, is probably the fastest way to run a blockchain. Is that assumption correct?
As I mentioned, there were three. There are three types of MPC solutions out there. One of them is fully homomorphic encryption that I mentioned. The other is based on secret sharing. And the approach that we take is based on garbled circuits. And if you look at them, then FHE and the secret sharing based solutions, they are forming some scale, and they are positioned in the both extremes of this scale. Where FHE is very inefficient on the compute, but very good in number of required interactions, because everything theoretically can be done locally by anyone who holds the ciphertext. But in the secret sharing approach, in every operation, the parties have to interact.
To communicate, yes.
To communicate, and this makes the communication part very expensive. But the operations themselves between each round of communication, the operations themselves are very simple. So
low on compute, high on communication versus high on compute, low on communication.
Yes, exactly. So garbled circuits in like the usual usage of garbled circuits for MPC, it is on this scale. It is more close to. It's actually in between. It has very good compute. It is very cheap on compute, and it's also, as I mentioned, it only requires several constant number of communication rounds. It does require rounds and like back and forth between the parties, but it's constant and it's not high. And what we managed to achieve here is even reducing the number of interactions such that it will benefit both efficient computation and close to zero number of interactions. So it will gain from both sides of both extremes of the scale, and for that reason, we believe it will be the optimal solutions for blockchains.
That's amazing, and obviously some are familiar with what is called TEE, or secure environments, which is very good in many ways. But as my understanding, that the big problem is that it's not secure nor private. These systems are getting hacked into quite a lot. We've seen a lot of press around this, so this is why it's off the table, because it doesn't serve the purpose. So just to summarize, gobbling circuits are better than these secure environments because gobbling circuits have proven to be secure versus trusted environments that are not really trusted or secured. Zero knowledge is not very efficient in terms of computing, but its irrelevancy to privacy is because it doesn't allow for interoperable solutions or applications that require more than one user. And this is why it's not interesting for us. Secret sharing type of MPC or fully homomorphic encryption type of MPC fall on one side of the scale. Either they are very expensive on compute, but low on communication, or cheap on communication, or very expensive in terms of communication and cheap on compute, like secret sharing is. And both aren't ideal when you're sitting there on one side of the scale, especially for blockchain where latency is always an issue. In terms of use cases, how is this technology primarily for? What are the use cases that can be done with this?
So there are obvious use cases that are very popular in the real world, like voting. So, for example, when tokenization of shares in a company will be popular, then
like real world assets, you mean?
Yes.
Yeah.
Then voting is a very common procedures in companies and shareholders, and this can be conducted with privacy.
Yes.
Over blockchains very easily by simple smart contract development.
So it is with DAOs as well, right? Because the obvious problem with voting in a non-private environment is that it becomes biased because people are trying to vote for the winner and so on and
exactly.
so forth.
So votes become dependent on each other, and also when your vote is public to everyone, then you want to vote,
become a target. Yeah.
Yes, you become a target, and you want to vote as expected rather than upon your opinion.
Sure.
And there are actually research papers talking about this bias of the results of votes when, like, in comparing the results of votes when it is under with privacy and without privacy, and there is a difference.
Sure. What about payments? That's quite easy.
So also payments, yes, this is the most basic use case for blockchains, and also here privacy takes a big role. Where you can transact, you can transfer funds to anyone without the amounts being revealed, and sometimes even without stating exactly which token you are transferring.
Sure. Which leads me to DEXs. So, like, obviously, one of the big things with DEXs is that institutions that require privacy as part of their mandate cannot really transact on DEXs. Like, they have weird ways of doing that, multi-wallets, etc. And also, whatever is proprietary in what they do, like their strategy is open, right? Yes. So that, I guess, is a big thing for privacy as well.
Yeah, so for DEXs, the DEXs are actually under threat in the blockchain space because there is this MEV issue, minor extractable value, where when your transactions are public, then everyone can see them and they can front run you and back run you and actually cause you to pay more on what you would pay otherwise.
Yes.
So you become a target. And with privacy for DEXs, this problem is being mitigated and it is becoming much harder to target transactions.
Okay, it sounds to me like with healthcare or learning or AI training, where sensitive data is required in masses to generate insights. This is something that has solutions in Web 2, but does not have solutions in Web 3. So your take on this?
Yeah, so I think that blockchains in the end will become as a warehouse for personal data for anyone. It will be the natural place to store data. And when we reach that point, then it will be very attractive for research companies and anyone who actually want to harness that data to come to that marketplace and get a permission from all those individuals to use that data. And since it's a public domain, the actual specification of the operations, that the actual conclusions that he harnessed from the data become verifiable. Everyone can see that only the conclusions are being revealed and nothing about the actual personal data. So
that's amazing, actually. Yeah, it's a brave new world, and this is why we feel blockchains will have their SSL moment. So at this stage, I know Sodal Labs is working on a few patents, but at this stage, what can you tell us about the research breakthrough that you guys have achieved?
So I cannot say much about this. I just, as I mentioned before, just taking the vanilla version of Garbled Circuit, even the state-of-the-art Garbled Circuit out there, from the literature and plugging it into blockchain does not give you the optimal result. And after some thought about it and research that we've done, we got to some modification to the usual usage of Garbled Circuits that makes our solution optimal for blockchains.
Amazing. So that's great. With that in mind, I know that this is not just research papers. Obviously, we've been working and actually producing code. And we've recently achieved a milestone that we'll probably disclose in the coming weeks. Can you give us more details about the recent development or the latest milestone that has been achieved?
Yeah, so right now we have reached a milestone where we can actually run our Garbled Circuit-based MPC solution between multiple parties. And this is done based on language. It's a kind of an intermediate language that we have developed specifically for that. In the near future, we'll transform that language to fit into the EVM language, which is actually the opcodes that are used in the EVM. And this will make everyone, it will make it possible for every developer to just code in the known Solidity language and gain that access to MPC with as little effort as possible.
That's amazing, because developers are what matter actually with this, and Solidity will make this obviously very easy. Which brings me to the next milestone, which is the DevNet. The DevNet that is planned for around April this year. What can we expect from DevNet? What can developers expect from DevNet? What's in store there?
So on our DevNet will not offer a full-fledged access to our MPC yet, but we still want to get developers the opportunity to work with, to have the same developer experience as they would have in a real system with MPC enabled. And with the DevNet, anyone can actually feel what it is like to develop smart contracts that support privacy. And when I say support privacy, it means that you can define every variable in your contract to be private or not private. Actually, the default is not private, and when you want it to be private, then you will specify that. And whenever we do some, we take that variable into some function, then that function will operate on this variable without opening it. So it will remain obscured all the way.
So that's amazing. So essentially in April, developers that will access the DevNet can deploy smart contracts with a new feature that allows them to obscure some variables.
Yeah, and we are targeting
and execute these smart contracts and actually see how it works in an app.
Yes.
That's quite amazing for April this year. So I would like to thank you for
Thank
taking the time. I know everybody's super busy and sharing all this info. Obviously, this is very exciting for COTI. With this type of gobbling circuits, we believe that COTI V2 will be, the best privacy-centric layer 2 over Ethereum, and this is just around the corner. So April this year, you can deploy smart contracts with obscure variables and build dApps, and we'll talk about this more in the future. The next big thing for us is obviously to unveil the latest Milestone, and we'll get into that too. Thank you for being with us. Avishay, I'm sure this is not the last time we speak in this environment, publicly and not privately. And thank you all for joining in.